Today in class we talked about exponential growth and exponential decay models. And a model is really just a general formula that you can use for a specific problem. If you look here, it says when a real life quantity increases by a fixed percent each year, the amount y of the quantity after t years can be modeled by the equation y equals a times 1 plus r to the t power. A is your starting amount, r is your percent increase, and you need to write that as a decimal. So if it's 15%, you would need to write that as 0.15. And then 1 plus r together is considered your growth factor. So if you look at this example down here, it says in 1996 there were 2,573 computer viruses and other computer security incidents. During the next 7 years, the number of incidents increased about 92% each year. So the first thing it asks you to do is to write an exponential growth model giving the number of incidents after t years. So that means write a general formula that you could use for this specific problem. Well, what this is saying is we started with an amount of 2,573. We increased by 92% or 0.92 each year, and for right now we're going to leave that to the t power. Okay? The only thing I might do to this is instead of leaving it as 1 plus 0.92, I am just going to write that as 1.92. And so this is our model that we can use for any number of years. Okay? It then says about how many incidents were there in 2003. Well, in 2003, that would be 7 years after the starting year. That's telling me to put in a 7 as the exponent. And if we calculate this out on the calculator, you would just type in 2,573 times 1.92 to the power of 7. Oops, I typed that in wrong. Hold on. 2,573. There you go. I switched my numbers. There we go. All right. So you have about 485 computer viruses. If you look down here at this problem, it says suppose you deposit $2,000 in a savings account. There's your starting money. And it pays an interest rate of 4%. There's your R. It says if no money is added or withdrawn, answer the following questions. Well, let's first come up with a model. The amount of money in our account, we started with $2,000, and then we are increasing by 4% each year for a certain number of years. So there is our model. For part A, it says how much will be in the account after 3 years. Well, that tells you to put 3 in for the exponent. You'd have $2,249.73. Okay. After 18 years, well, that means change the exponent to an 18. You'd have about $4,051.63. Okay. Now, if you look at question C, it says, how many years will it take for the account to contain $2,500? Well, this isn't asking us to put 25 in for the exponent. It's asking us basically to figure out what the exponent is. And there is a pretty easy way you can use the graphing calculator to figure this out. What you want to do is you want to hit the y equals button at the top. And that will get you to this screen. Then you need to type in your general equation, 2,000 times 1.04 to the power of. Now we don't have a t button on here, but this button next to the green one is the x key. Use that as your exponent, okay? Now instead of looking at the graph, I'm going to use the table function, and I'm going to look for which year did it reach $2,500. Now if you look down here, there is not one where it reaches exactly $2,500, but if you look at year 5, it ended that year with $2,433.30. Well, it ended the year with not quite enough. Year 6 ended the year with $2,530. So what we do know is sometime in that year, it actually hit the $2,500 mark. And so the answer would be in 6 years. Now, exponential decay is really the same type of thing. The only difference is that instead of 1 plus r, with an exponential decay, you are decreasing by that percent. So if you look down here, it says a new snowmobile costs $4,200. The value of the snowmobile decreases by 10% each year. So when it asks us to write a model, it's going to look like this. The starting price was $4,200. and we decreased by 10% each year. Now I would probably write this model as 4,200. I would do 1 minus 0.10 and get 0.90. And so that will probably how you will see an exponential decay. And then from there, you could plug in 3 for your exponent and solve for the price after 3 years.